thank everyone for coming here. All right, so I'm so grateful to be here. This is such a beautiful space, and you can almost like look around the grounds and look out at the water and feel the history. I don't know if anyone else is experiencing that right now, but it's beautiful and I can feel the history, and I think it's so relevant to what we're talking about right now. Because decisions were made on this estate throughout history that changed the course of industry, which is exactly what we're talking about today. So for instance, if you can think back to the Ford Coupe in 1932, that's where the decision was made in this estate to democratize the V8 power. Also, during wartime production, the B-24 bombers at Willow Run, I mean, this is the history I'm talking about that was made here. So thank you for coming here. Today, we are going to look to history and continue that legacy of these transitional and important discussions. So, I'd like to thank everyone for coming. It's important to have these conversations, to convene, and to share ideas and experiences and thoughts about moving forward during challenging times. And right now, when I say challenging times, we're all experiencing a transition in the economy, and then also these fast-pacing technology adoption challenges that we're all facing. So those are the things that we're going to talk about today. I'd like to thank our sponsors. We have sponsors here from our previous roundtables, our previous Integrate roundtables. So we have Michigan State, Oakland University, Butzel, Ulendo, and Stratasys. So thank you to our sponsors. I'd also like to thank our partners, MMTC, the MEDC, and SME. There's a lot of letters there, so thank you to our partners as well. We have a lot of Automation LA members in the room, so welcome. We love seeing you. If you are here and you are not a member, thank you for coming. It's wonderful to meet you, and we really recognize that every single voice is important in these discussions. So we're happy to get to know you. Thank you for engaging with us. If you're interested to continue to work with us, come see me, and I'm happy to talk to you after the event. George, Dan, really anybody from Automation LA can help talk to you about further ways to engage with us. Caitlin can help you, Caitlin. So thank you for coming. All right, so as you know, this is our network event as part of our Integrate series. We still have a couple roundtables that we are hosting. We have one coming up on global trends, and then we have another one coming up in September on mobility. So look for those. The global trends one is in August, and then we have another mixer in October. My notes say that the location is to be determined. There's a strong possibility it'll be at Michigan State in East Lansing. Go green.
Go white.
That was weak. Go green. There it is. All right, so look for that. We're not sure about the location. We're working on it, but that's what we're looking at right now. Okay, so we're going to have a panel right now. I'd like to introduce our panelists. So first off, from MMTC, the president of MMTC, Ms. Ingrid Tai. I'm going to actually come down here so that they can all sit down. Yeah, you're good. So from MSU, Associate Professor of Mechanical Engineering, Mohsen Zainari. I hope I pronounced that. Did I pronounce that okay, Mohsen? Okay, good. Butzel shareholder, Claudia Rast. And Ulendo CEO, Brenda Jones. And please welcome our host, our panel host from WWJ News Radio, Jeff Gilbert, an icon known for covering Detroit's automotive industry. Welcome, Jeff.
Thank you.
Okay, so on your table, you've got some QR code on your the center there. I would encourage everyone to scan the QR code. There's going to be some questions. We're going to use those questions to help us shape industry for our future integrate topics. So your input matters, and that would be helpful, so thank you. All right, let's get going. We are going to have a panel here, and then afterwards we're going to have refreshments and some drinks. So thank you for coming.
Thank you. Thank you very much. I'm honored being asked to moderate this. I did not know I had yet achieved icon status. That is probably a synonym for old, but hey, I'll take it. Anyhow, I am the auto reporter for WWJ, the old news station here in Detroit. And as I mentioned to our panelists, all of whom have so much more expertise than I could even guess at having, that my knowledge is like 2 miles wide and 2 inches deep. So that tends to be how people are in my business. We know just enough about things to maybe have a slight clue about how much we don't know. But this is a fascinating subject, and we want to, since you're all in this area, get your questions answered as well. So I'm going to ask some questions, but if you have a question, raise your hand, I'll bring you in, and I'd like to mix in your questions with my questions. But we're going to start with a panel with just sort of an open-ended question, just along the lines of where do you see the most immediate opportunity for manufacturers to innovate right now? I'll start with Ingrid, since she's on that end of the panel. We'll just work our way down with everybody else.
Thank you. It's a pleasure to be here, and thanks to everyone for coming out this afternoon. So I see the biggest opportunity for companies right now is with solving for workforce development. We see that every single company that we speak to has a shortage of talent in their companies. And so I4O, innovation, technology, all these different buzzwords we use, all this can help us for solving for that issue. We do things with our companies and our clients, like walking into a plant floor, and we might be able to recommend a cobot in a cell that can help do a task that a lot of employees really don't enjoy. It could be a dirty, a dull, or a dangerous position that either there's a high turnover or it's really difficult to fill that position. The other piece that is really helpful too is, again, with a shortage of folks, you can use things like software, like an ERP system, and you can help start aggregating data from the different pieces of equipment on your floor to understand what is happening. You can use sensors on your pieces of equipment so that you can do and improve your machine monitoring, so you understand when a piece of equipment might be going down or that you have to do maintenance, because you can't be everywhere at once. But this will help you from a central location to be able to monitor and manage that more efficiently. So those are some of the immediate things when you think of the technology. And the other piece is supply chain. AI is a great tool that you can use to help you, again, find out who are the vendors out there, the other sources that might have materials that you need. They can find out supplies of certain types of equipment or pieces that you need, or find out more information about what's happening in the supply chain. So those are two of the immediate things that I can think of right now.
All right, hello everyone. I'm very glad to be here. The term I would like to coin today is AI for AI. The first term stands for artificial intelligence, but the second one stands for advanced integration. Advanced integration of what? Data. Well, when we look into every processes involved in advanced manufacturing, especially additive manufacturing, you are inherently dealing with a multi-physics, multi-scale, multimodal problem to solve, actually. And with that is involved with a large array of different types of data that you work with on a daily basis. Well, in such a big data set that you are dealing with on a daily basis, we've been really suffering of a term called curse of dimensionality. And AI seems to be a wonderful alternative approach to incorporate diverse array of data that will let you do multi-purpose optimization for developing a final product and that will lead to a better marketability and options for the customers. I can elaborate more on that and provide more details, but I would love to hear my distinguished panelists on this subject as well.
Thanks, Bush, and thank you, Jeff, and thank you everybody for coming. It's a beautiful day. AI, it's everywhere. You know, and as the lawyer in the crowd here, the geek lawyer, I proudly call myself a geek lawyer because I have a science background. Part of AI is how to do it in a smart way, a safe way, in a way that really is efficient, because AI in the wrong hands, in the wrong way, with the wrong algorithms, is a disaster. My comment on where we are and how we're doing this is one word, and that's resiliency. We have to be resilient about where we are, what we're doing, how we're doing it, and our supply chain. Who are we connecting with? Who are we including in our house, so to speak, to work with? And it requires a certain additional due diligence that we never had to have. We need to understand our contracts, so I'm a lawyer, which is really, really important. I had a conversation today about a company who had a data breach, and we're talking about, you know, the statutory obligations and who you notify and everything else. I said, who are your contractual partners? You have an obligation of confidentiality. What are you going to do? Resiliency is a matter of embracing the vulnerabilities and the threats and the risks and still operating your business.
Excellent. So I'm going to answer this question from the perspective of a company that provides hardware and software to the end manufacturer. The dynamic that we're seeing in additive manufacturing, that's the particular part of this industry that I'm familiar with, 3D printers. What we're seeing is a migration away from assuming that you can have a 3D printer that just prints anything, just across the board. And in my other answers, I'll reflect back to some of the points that are in the latest playbook about how we've gone from hype to reality. One of the major shifts is a migration away from platforms that cut across applications to very, very specific applications in manufacturing, where multiple parties have to coalesce against a very, sometimes narrow problem and solve that problem, as opposed to producing software and hardware that's supposed to just provide a generalized solution.
And we'll start with you with the Q&A. You know, we were talking about this ahead of time. So many people think 3D printers are plug it in and it'll print anything for you. But correct me if I'm wrong, my impression is 3D printing is great for things like prototypes, small manufacturing, things that are specific, but it's still not quite ready for mass manufacturing, or is it?
You have that right. So the beginning of the hype actually started when President Obama, sorry, I messed up his name, mentioned in his State of the Union that additive manufacturing was going to be a thing of the future. You could watch a graph of the number of 3D printer manufacturers go whoop right after he made that statement. What that meant, though, was, and people were saying, oh, there's going to be a 3D printer in every home. Well, certainly we haven't gotten to that, because what started to happen was there was this assumption, oh, you just buy a 3D printer, you can print anything. And the assumption was it would migrate away from its beginnings, which was in prototyping, early product development, all the way to high volume manufacturing. Well, we've gone from hype to reality. The rubber hits the road when you try to now use these kinds of machines to reliably make parts that are the same quality, same shape, same tolerances. That's where we've hit the wall as far as getting consistency of manufacturing parts and actually getting them qualified. Because in some industries you have a very long qualification process where you have to say, I know that if I make this part this way, part 2 is going to come out the same as part 102.
Some points to your point, I would like to say that it took us about a century to fully understand the behavior of materials. We developed mathematical theories governing equations that describes the behavior of fluids, solids, and we expanded them into viscoelastic plastic materials, okay? And just imagine how much design, how much philosophy of design was basically developed over the years in order to get to the old state of manufacturing. So now the revolution that Linda is talking about is when we had powerful computers, where we could do three-dimensional modeling of mechanical systems. And with the whole computational mathematics ability that we developed commercial softwares that you could do an array of engineering analysis over those three-dimensional objects, and you connected that to additive manufacturing and 3D printers. Now, what's wrong here? Well, and the role that AI is going to play in here is to say that every single physical process, and it corresponds to a mathematical model, and you have a system of those mathematical models that need to be treated, to be solved and integrated. Well, AI wants to say, don't do that. It's expensive, it has its own sources of uncertainties, and you can make a connection between the input to the process and the final output, which is your desired, basically, output product. So just imagine how much diversity of data you have, and now AI would be able to incorporate all of that. As you are exercising at additive manufacturing, you're producing data as well, and you can use basically a new sense of quality control. It's basically active quality control, and it's integrated, which means that you can use that as a feedback to the very process of additive manufacturing. And this is one area that would allow us to create a really array of options: cost, reliability, lifespan, predictability, and basically prediction of the mechanical properties of the final product with uncertainty bounds. And believe me, this creates a beautiful marketability because your customers will be able to pay a certain amount of money for a certain quality to get out of the whole product. You want to increase the cost, it means that you are increasing the reliability and you are increasing the lifespan, and that would be a kind of a change in the data that you feed into your machine learning algorithms, and they will give you a kind of a slightly modified recipe for additive manufacturing. Therefore, if you want to do quick production of the products where you don't care much about that quality, because that is going to be used in the field for 6 months, for a year maximum, after that you don't care about that, then that will require faster prototype making in which all the physical processes have been taken into account in the language of data. So I think this is something AI has been shown to be a wonderful tool to incorporate a variety of data, policies, in order to achieve a variable quality and variable basically performance in the final product. And it's something that can be integrated into what we have right now.
Ingrid, you look like you were going to...
Well, I wanted to add a comment. You said something about small, but I want to also say that it doesn't have to be small. Additive and then combined with AI has actually opened up opportunities and development in large. And one of the things that AI allows companies and manufacturers and engineers to do is you can now create complex geometries that we couldn't create before or had more challenges before. And there's an example, so for instance, a company in Cleveland, Lincoln Electric, we did a tour down there, and there is in construction a TKY joint where they showed us the large pipes where historically those would get welded together. Well, at those welds we know that those are weaker than the actual pipe itself. But now, because of AI and then also additive manufacturing, you don't have to have that traditional TKY shape, but now it can be a different shape and a different geometry, and they have these 10-foot prints, 3D prints at their facility, these huge, large, and all different materials that they are making for defense, for ships, and others. So you have GEs in this space, and there's some other larger companies that are doing this. So it is starting to revolutionize our creativity, if you will, and what we can create. So I think it's just opening up this whole new world for engineers and for design.